This law, often mistakenly attributed to French physicist J.A.C. Charles as Charles' law, was actually discovered and established by Joseph Louis Gay-Lussac. Gay-Lussac's law refers to the relationship between the temperature and pressure of an ideal gas and was first published in 1809 after being discovered in 1808. According to this law, the pressure of a given mass of gas at a constant volume varies directly with the absolute temperature of the gas.
How is it possible? If a beaker is placed over a burning candle, the flame will gradually decrease until it is completely done. As this happens, the water level underneath the beaker will rise for a brief period and will continue to do so even after the candle is out. The water level underneath the beaker will be significantly higher than the water level in a shallow dish. This phenomenon occurs because as the temperature rises, the pressure increases, and as the temperature drops, the pressure decreases. The beaker is filled with gaseous air molecules that get excited by the energy transfer from the flames, which raises their temperature. As these molecules try to expand in volume, they press against the walls of the beaker and the water at its base. This increase in air pressure under the beaker causes the water level to be pushed lower than the water level outside of it. The higher the temperature or energy of the air molecules, the more pressure is created under the beaker.
As the candle flames burn, they use up some of the oxygen in the beaker for combustion, which produces carbon dioxide gas and water vapor. As more of these gases are produced, they fill up the top of the beaker and force the oxygen levels to decrease until the candles are extinguished. Once the flames are out, the air molecules under the beaker begin to cool down and lose their excitement, causing the pressure they exert on the sides of the beaker and water at its base to drop. This pressure drop causes a pull on the sides of the beaker and water at its base as the air under the beaker seeks to equalize pressure with the outside, as it is easier to pull water into the beaker than to collapse its side. The water in the shallow container is pulled into the beaker, raising the water level underneath and equalizing its pressure. By changing the temperature under the beaker, we can observe directly proportionally relationship between the temperature and pressure of an ideal gas, which is known as Gay-Lussac's law.